Center. I would like to welcome all the distinguished participants and speakers for today's webinar on the disposal and recycling methods for solar panels. I am Danin Janso, Research Fellow at the SAARC Energy Centre, and today I'll be the moderator for this webinar. For the benefits of the participants, the first presentation will be done by Mr. Fang. Mr. Fang is a program officer at the International Renewable Energy Agency. And the second presentation will be followed by Mr. Jaidev, consultant Managing Director of Maliyaware Solar Energy Consultant. And the process of the webinar is that firstly, we'll have a presentation from both the experts and thereby followed by question and answer sessions. In the meantime, the participants are requested to raise your questions through the chat forums so that we can address at the end of the presentation. Unfortunately, today, Mr. Abdul Rashid Johiki, Director of SAARC Energy Centre, is not able to join. So I will read his opening remarks on his behalf. So, dear participants and speakers of the webinar, welcome to you all. It's my great pleasure to welcome you all to this webinar on disposal and recycling methods for solar panels. In pursuit of mandates entrusted to the SAARC Energy Centre, SAARC Energy Centre since its establishment is conducting various studies and training in energy sector of the region. In addition, SAARC Energy Centre is also reaching out to broader audience through webinars on different topics for the benefits of the member states. Ladies and gentlemen, among the various decarbonization initiatives being undertaken by the governments worldwide to achieve net zero emission targets, the large-scale deployment of solar energy and battery energy systems have emerged as one of the most preferred options at the present juncture. The rapid decline in technology cost, improvement in efficiency, and increasing policy support have accelerated the deployment of photovoltaic systems and battery storage systems. As per the International Renewable Energy Agency ARENA, global renewable energy capacity reached around 5,149 gigawatt by the end of 2025, of which solar accounted for around 2,400 gigawatt, representing approximately 47% of the total renewable energy capacity. The SAARC region has also witnessed significant growth in solar energy deployment, with total installed solar capacity estimated at approximately 200 gigawatt, led predominantly by India and Pakistan. With the rapid development of solar PV systems and battery storage technologies, it is important to create a concern that the management of the end life of the equipment should be the concern of especially the participants or the beneficiaries of the member states. PV models typically have an operational lifetime of approximately 25 to 30 years. Consequently, the increasing volume of solar installation worldwide is expected to result in substantial increase in PV waste in coming decades. Under a regular loss scenario, global PV waste is projected to reach approximately 1.7 million tons by 2030 and nearly 60 million tons by 2050 as per ARENA. Therefore, while solar systems and battery energy storage are critical technologies for achieving net zero emission objectives, establishing effective system for the end life of management is equally important. Developing appropriate policies, regulatory frameworks, collection mechanism, recycling infrastructure, technological capabilities, and regular cooperation for the responsible disposal, recycling, reuse, and repurposing of solar panels and batteries will be essential for ensuring that the clean energy transition is both environmentally sustainable and aligned with the principles of circular economy. Dear participants, we are privileged to have distinguished experts with us for this topic. Mr. Jinli Feng, Program Officer Elna, and Mr. Jaideep N. Malavia, Managing Director, Malavia Solar Consultancy India. Their presentation will provide valuable insights into the ways of achieving circular world by adopting sustainable measures for disposal and recycling of solar panels. I hope that this webinar will be fruitful and will help in enhancing knowledge and understanding of the participants. So with this remarks of the director, now firstly, before we start the presentation, I will briefly introduce the speakers for today's webinar. First, Mr. Jenny Fing, Program Officer and Policy Advice at the International Renewable Energy Agency based in Dubai. His research work at ARENA focuses on policies for the deployment of renewable energy in end-use sectors, power energy, and sustainable bioenergy. He leads ARENA's projects for the environmental impact of renewables and circular economy for the energy transition. The second speaker we have today is Mr. Jaideep N. Malavia. Mr. Jaideep is a professional in solar energy since 1996, and he is the managing director of Malavia Solar Energy Consultants. He is also a board of director for Solar Energy Society Germany. He has over 32 years of experience in solar energy industry as a consultant, researcher, trainer, and developer. He worked as a research scientist at the Tata Research Institute, Delhi. He was a task force member for set up by the government of India on circular economy in solar panels on policy frameworks. So with this, now I'll request Mr. Feng to go with the presentation, please. Over to you, Mr. Feng.
Thank you very much. Let me first share my screen. Okay. Can you see my slides?
No, it's a product.
Yes.
Okay, thank you very much. So good morning, everyone. So first, I would like to thank the invitation from SAARC, the Energy Centre, for inviting me to join today's webinar and share our work related to the end-of-life management of solar PV and the circular economy. So I come from the International Renewable Energy Agency, and most of my work is doing the research on policies for different aspects of the energy transition. So one of the topics include how we're going to handle the decommissioned and end-of-life management of the renewable technologies, especially solar PV, battery, and others, and also how we can promote circular economy to incentivize the industry and also ensure the sustainable practice. So Today, I would like to briefly share our work from the International Renewable Energy Agency on how we suggest about the end-of-life sustainable management of end-of-life management of the decommissioned solar PV and our understanding about the circular economy from the global level. And I will also share about our estimation of the future weight of the end-of-life solar panels and our policy recommendations for different countries. So first, I would like to give some background. This is based on IRENA's data. If we can see the solar PV in the last 10 years, it has significant increase. If we can see the left side, 2016, the global solar PV installation, the total installation globally was only 293 gigawatts. And its share by that time was around 15% of total installed renewable. But after 10 years, if we can see the right side, the global installed solar PV has reached over 2.3 terawatt. So its share has increased to 46% of total renewable installation, the largest share. So in last year, 2025, global newly added renewable energy capacity, almost 3/4 was from solar PV, and it has rapid increasing and playing a very important role in promoting and accelerating the global energy transition. And in the meantime, we also found that the supply chain development and also technology and innovation has pushed down the cost of solar panel. That's one of the main driver of the deployment. And if we look at the future, and our estimation is that if globally the world would like to achieve the energy transition that aligned with the Paris climate target, we need further accelerate the deployment of solar PV and all the renewables. So according to IRENA's 1.5 degree scenario, if we can see that most of the major economies globally, they need to rapidly increase the installation of solar PV by 2030 and 50. 2030, you can see it's a dark red, this bar, and also if you can see the green, that's our estimation for the needed solar PV in major economies, different from several economies for 2050. So actually by 2050, we estimate that in a scenario that aligned with global Paris climate target, the solar PV installation would need to contribute around half of the total needed renewable capacity by 2050. This means from now to 2050, globally, every year, there would need investment at least $330 billion every year, the investment for solar PV deployment globally. So also we can see that not only the European, China and Australia, but also India and other South Asian countries would also need to accelerate the deployment and play a very important role in the global energy transition. But if we see another side of the energy transition, we have tried to estimate what does the rapid increase of the deployment means for the supply chain and for the material consumption. Because if we say the energy transition requires rapid increase of the installation also also indicate a rapid increase of the material demand. For example, the solar panels, if you look at the crystal, silicon crystal, the type of the technology, we can see that they need the aluminum and glass, copper, silver, silicon, and also different plastics. So we have found that we compared estimation of the average level from 2014 to 2024. We have made comparison of the material demand for solar panels, the change in the last 10 years. We found that from 2014 to 2024, globally, per megawatt of solar panel, the weight of the material decreased by 20% because of the technology advancement. Need more thinner material or less, but also higher efficiency. But we also see that because of the rapid increase of the installation, as I mentioned, that from 2015 to 2025, the deployment increased significantly. So also from 2014 to 2024, the total material demand for solar panel globally increased by 7-fold. That's because of the installation, the scale of the installation. We also assume that by 2030, the material demand for solar PV panels will be almost double of the current level. So this is also just our estimation, maybe because we do not include the estimation of the mounting structure. We only focus on panels, so a lot of estimation and also forecasting could be much more higher. But this is only for us to understand what does it mean for the supply chain and how we're going to prepare for that. And also we estimate that by 2030, the annually material demand for solar PV panels in the 1.5 degree scenario would exceed 32 million tons globally. This is also not consider the processing loss or something. It's just about the scale, what the solar panel material demand would look like in the next 4 years. And also, for example, I give you an example. We also found that this is just the weight change. But if we look at a different material, for example, we see that the material demand also changes significantly. If we look at the 2040, we estimate that like silver used for connection of the solar panels. In 2014, the silver consumption for industrial consumption, the silver material consumption for solar panel compared to the total industrial consumption in 2014 was around 11% globally. And after 10 years, in 2024, it increased to almost 30%. This is one example, but also other demand also increased. Another question would be how the world going to handle the end of life for solar PV panels. We estimate that globally, the commissioned solar PV panels gradually emerged in some of the markets because of the early deployment, because of the early use, also because of some of the during process installation. But it's not yet in the rapid increase. So we estimate that currently the globally decommissioned solar PV panel is around 1 million tons. But the estimation could be different because of the context-based estimation could be very different, and their estimation could be more specific. And but we need to remember that majority of the current solar PV panels which are operating, they were just deployed in the last decade. Let's say 80% or 88% of the total installed solar PV panels globally, they were deployed within the last decade. So, which means they have around 25 to 30 years of service life. Most of the operational solar PV panels, they are not yet reached to their end of the service life. So only the European Union continues to record that. But we see that in the 1.5 degree scenario, globally, the solar PV panels, if we can see in the next decade, 2035, the cumulative would be more than, let's say, 12 million tons. But majority of these to be decommissioned solar PV panels would happen in, like, let's say, European Union, China, America, Japan, and also the Republic of Korea. These countries would likely need to handle millions of the decommissioned solar PV panels in the within a decade. And by 2050, we estimate that globally the end-of-life solar PV would reach over 200 million tons, the cumulative. And by 2015, some of the major markets like European Union, China, and the US, the decommissioned solar PVs in these three markets will contribute to 30% of the global weight. And we see that this is just the weight, but also we can see the annually end-of-life solar PV panels will be more than 20 million tons by 2050. This requires a lot of infrastructure, but also the industrial capacity to handle these end-of-life solar PV panels properly. So this is something to show that our estimation on the annual end-of-life solar PV panels in several markets. If you can see, not only just other, but one of the markets you can see from India, we estimate that after 2040, the annually end-of-life solar PV in India would be more than million tons scale. This is only the panel. Does not include the estimation on the mounting scale and some others. So, but you can see in the next 10 years, the scale of the end-of-life solar PV annually in most of the markets still not yet reached the million tons, which means we also need to consider the capacity, how they can operation properly, and also reach the enough feedstock. And also one observation we have found that the end-of-life solar PV, we compared the estimation of the weight of end-of-life PV by 2030 and 2050. We found that by 2030 and now, the end-of-life solar PV compared to the global weight, the total weight of the e-waste less than 1%. But if we look at 2050, the end-of-life solar PV panels, their weight will be more than 20% of the total weight of the e-waste globally. So we have found that there are different end-of-life management roles for solar PV. Some of the majority of the world still not yet established the dedicated collection and handling. Some of that still follow the industry waste policy like Japan, but also like European Union has established a dedicated system for the management of the PV waste, and they are established the systematic recycling and handling system. But also here to show that the different steel mixing in different markets, and we have found that, for example, one of the market, European Union, they have reported systematically about the collection and handling of end-of-life solar PV in the last several years, and we can see over 15,000, almost 60,000 tons of end-of-life solar PV reported in 2023, and the majority came from the Germany and Italy. These countries deployed solar PV panels in the early year, but also some other countries, their weight on the end-of-life solar PV are increasing. And we found that one of the observations we found that even we have the different treatment roles about the end-of-life solar PV, but if we look at if we adopt a circular economy approach for decommissioned solar PV, there could be many benefits, including the economic benefits. For example, not only just providing the raw material for the material, but also we have estimated the market value of this recycled material from the end-of-life solar PV by 2030, 40, and 50. We estimate that annually the recycled properly and systematically recycled material such as silver, copper, aluminum, glasses, and also silicon from the solar panels, they could contribute over $6 billion of the market value by 2040, and it would reach more than $20 billion by 2050. And this not only for the market value, but also could contribute to the development of the local industry capacity, because the circular economy requires the development of the recycling, handling, collection of all these decommissioned solar PV panels. But they also face many barriers. We can see one of the barriers is information, but also the cost effective and logistic cost could be very expensive. But also one of the key issues I would highlight about the barrier is there's low economic return for recycling. And it's linked to also about the technology, about the infrastructure, but also the market confidence of the second-hand producers is still need to further established. And another key barrier I would like to mention is the unregulated recycling activity, and also it could affect the market development, and it exists in all the markets. And finally, I would highlight that solar PV remains one of the most important energy transition technology, but the decommissioned weight in the future would need our attention and to address all the concerns about the waste stream. So even we have all these barriers, still the markets and the regional stakeholders need to address this by adopting holistic policy framework. So we highlighted some of the policy and the tools that have been adopted by countries like environmental regulation, mandatory requirements on the financial responsibility, and platform reporting. All these, and also international collaboration, especially regional platforms. And cross-sector collaboration also very important because it's pushed the technology advancement and the pilot projects. So, and here's the stakeholders. Maybe I will skip here. And if you have more questions, I would like to share more details all these aspects later in the Q&A session. Thank you very much.
Thank you, Mr. Fang, for your excellent presentation covering global perspectives, mainly on the present status of solar development and how the development of solar will increase in the near future, and along with it, the amount of waste to be generated at least by 2030 scenario and 2050 scenario, and the monetary value of the waste generated, and how we can inculcate in our daily policy making so that those values can be harnessed in the future. So thank you very much, Mr. Frank. So now I go with the next presentation. Mr. Jaidev, are you online?
Yes, very much. I'm online. I hope I'm audible.
1 second.
Namaskar to everybody. Yes.
The next presentation is Mr. Jaidev from India. He is a managing director. The previous presentation we have heard for the participants, for the basis of the participants, the previous expert has covered on the global perspective of setting of a plans for recycling of solar panels. And Mr. Jaidev, though he has a global perspective knowledge and this thing, but more relevant to the sub-region he will be covering on the ways or the efforts made by especially India in setting up a recycling solar plants. So with this, now it's over to you, Mr. Jaidev. Please go ahead.
Okay, thank you very much, everybody. It's a pleasure and to address the August gathering of the South Asian Association of Regional Cooperation. Thank you for providing this opportunity. Is my screen visible?
Yes,
Yes, sir.
The presentation screen.
Yes,
Yes, sir. Yes.
Fantastic. So, can I know how much time I have so that I make
No,
the
no,
presentation?
we have time. Please go ahead till you finish your slides.
Okay. I hope to make an interesting presentation
Sure,
based
please
on
go ahead.
my last 7 years of research in this solar panel circularity, as I would put it. And we say it as plus from surplus for us. So the word surplus is what matters. Okay, and we'll come to that. What is plus, what is surplus, what is us? Solar energy is today the most spoken about renewable technology, the most progressive. So let's understand first between a linear recycling and circular economy, because largely we'll be focusing on circular economy. A linear economy is you take, make, use, waste, and just throw away. A very common thing we do for most of our items we consume. In a recycling economy, you do take, use, some goes in the waste, some is again upcycled or downcycled. That's what we use. But eventually, when it comes to an end of life, it has to go in the landfill sometimes, despite recycling multiple times. Whereas a circular economy ensures nothing goes in the landfill. And that is what will be truly addressing to the climate change. Adopting circular economy is crucial to address global warming, reduce import dependency, and address health of mining workers. So something on the social side. We just can't keep mining to fulfill our needs. I think I'll skip this because the previous presentation already covered about the global scenario. And since most of the references are given out of IRENA, so the global solar PV market at end of 2025 was almost like a 3,000 gigawatt peak that consumed about 187 million tons of raw materials. Can you imagine? The global market for materials recovered from recycled solar PV panels is projected to reach $810 US dollars by 2030, $6 billion by 2040, and will exceed 20 billion by the year 2050. So that's the business opportunity. Massive opportunity. This itself will be a massive industry in itself. And since I come from India, I'm just being a bit biased, but India will be in the top 5 solar scrap generators. We avoid using the word waste because waste is wealth. So let's not use the word waste. Germany, India, Japan, US, and China are the markets to be looked forward to. Already these figures were shared by the previous speaker, so I need not repeat. India's target is about 300 gigawatt peak by the year 2030. And we are well on course. We have achieved about 175 gigawatts so far. We are now the third largest market. In 2025, the growth in India was second highest to China. And it is hoped by the year 2047, when we complete 100 years of independence, we'll achieve about 1,000 gigawatt peak. That massive volumes we will have. Who would be dominating then the solar PV market? Undoubtedly Asia, as you can see in the graph on the left. And amongst the Asia, China will no doubt be the leader. I mean, combine all the other countries and China itself will be like comparing apple to apple. But the focus would be now on Asia. Asia will be the center stage for the forthcoming solar energy development. For 2 reasons. One is, the entire South Asian region particularly is a tropical region. And with rich sunlight, they are going to convert this. Probably they may even export to the other countries. That's what is the vision of our Prime Minister of one sun, one world, one grid, OSWOG, as it is put. One sun, one world, one grid. Hopefully. Anyways, let's not talk too much of the future, but what we have in place. Now, considering this massive growth in India, in 2022, India made solar panels and cells mandatory to safely dispose at the end of the life. So we'll use the word end of the life instead of using the word waste. Under e-waste regulation, I was fortunate enough to be part of the regulation team when this was framed. And all the producers have to generate extended producer responsibility certificates. So India today is perhaps second after European Union. I stand corrected if there are any other countries who have come out with mandatory regulations. What I'm told is now even China has, and the eastern part of US, that is around New York region, has a mandatory law. So, but however, I'm not clear on that and I don't have on records. Now, the very definition of a producer is one who manufactures or one who is branding under the OEM. OEM is original equipment manufacturer. So, after all, it's a manufacturer, but they will brand it in somebody else's name. Importers and second-hand traders. So, even if you're importing, the importer is liable to generate extended producer responsibility certificates. Failure to fulfill these regulations, the penalties are very heavy. And this is what has led to a trigger in the market to start exploring now solar panel recycling in India. Again, I'll come back to what the previous speaker shared about the share of raw materials. Largest being the glass by 70%, followed by aluminium, which is about 80%. So these two make 88% by weight. That's the share of raw materials. And then you, of course, have the polymer materials like the encapsulation layer, the back sheets. Then you have the solar cell, which has the silicon, copper, silver, tin, lead. And then, of course, there are traces of your semiconducting materials, but there are hardly any. And of course, at the back of your module or the panel, as it is called, you have the junction box where there are connectors of copper and aluminum. So the cable doesn't become part of it, okay, as of now under the regulation. The next slide. The 300 gigawatt peak target, look at this colossal raw material requirement, massive. Close to like 13 million tons of glass, 3.3 million tons aluminum, 1 million tons of silicon and copper and silver added. It's noteworthy. Majority of the raw materials used in the making of the solar PV modules in India have the metals categorized under critical minerals. So the targets are huge. The ambition is very high, but securing the raw materials will become challenging because the import dependency is there owing to the criticalness. This is based on a research study we undertook. That gives a perspective of the critical minerals or the net importer that India is. So almost everything that goes in the making of a standard PV crystalline silicon module, which is what we'll be totally referring to, because thin film technologies are hardly any in India. Aluminum, silver, lead, silicon, copper, tin, phosphorus, everything if you see, either they are net importer or there is critical mineral identified. And that is what brings merit to solar PV recycling. So as I put it, it is not recycling more, but about recovering more. It's not about recycling more, it's about recovering more. The more you recover, the more, okay, you address your critical minerals. So if we are able to utilize our recycled materials back in the solar industry, which is what would be the ultimate challenge, then we would have fulfilled the circular economy. You can see this, how PV recycling is addressing critical minerals. Even if you take the other renewable components like the wind energy or the energy sources like wind energy or hydrogen electrolyzer, as a matter of fact, batteries, electric vehicles, everywhere, the critical minerals are being used, which is as far as India is concerned. Now, look at again the quantum of raw materials that can be recovered. So, the typical life cycles of a solar PV module, as they claim, is between 25 to 30 years. But I'll come to that. Now, it seems that these modules may hardly last 25 years also. They may see either an early loss. So from the regular loss, we may see an early loss. Okay, I'll come to that slide for certain reasons. But under the regular loss, if we see with a standard 25 years, so by 2047, massive amount of raw material can be recovered. So there are plenty of business opportunities, not only in India, wherever in Asia the markets are growing, you have a business opportunity in the entire South Asian region. Below is a photograph, of all the raw materials that are recovered by one recycler, an award-winning recycler from Germany, with whom we have entered now into a licensing agreement. I'll come at the end of the slide for it. As I said, I was part of the regulation committee. The Central Pollution Control Board is the agency which takes care of the entire ecosystem of the recycling, right from managing the collection of the raw materials. That is, it will monitor from the producers, it will gather the data and ensure that these producers have generated extended producer responsibility certificates from authorized recyclers only. So the list of authorized recyclers will soon be published. However, the regulation doesn't require it to do immediately. It says by the year 2034-35, until that you can store, but then from there onwards, you'll have to start recycling. That doesn't mean you landfill your modules. So April 2022 onwards, all the PV modules that have been produced have to be stored and later their extended producer responsibility certificate be generated. Now, why I've shown this slide is the best part is the value of your EPR, which is Q EPR, which is the quantity eligible. Okay, the certificate is based on the quantum of the raw material that you recover. So quantity of the end product, QP, into the conversion factor. Higher the conversion factor, higher is the value of your EPR. I hope you got it. Supposing if you say we recover 70%, which could be just the glass, and then you dispose of rest of the material, then the value of your certificate is hardly any. But if you say we will recover 98%, then the value of your certificate grows substantially. Of course, 100% means icing on the cake. Probably to give some relief, with year 1, they may start with 60%, followed by 70%, 80%, and year 4, it will be 90%. But however, now we are given to learn that they may probably link it directly to the highest capacity recovered. They may eliminate this particular formula over a 4-year period, but we are not sure yet. Now, where does the end use of the recycled materials presently go into? If you see, most of it goes into the primary use. A glass, of course, we have achieved a breakthrough in sending back to the solar PV recycling industry. The traditional methods which are being used right now, the rudimentary methods of shredding, doesn't help the glass recovered go back in the solar industry owing to its poor quality, because the polymer materials and the other silicon cell-based materials still have contaminants pasted in the glass and you don't find value. So it will at most go to a primary white glass packaging industry, which is your bottles. Then the biggest challenge, of course, is your polymers. Recovering polymers is challenging today. There is a lot of research and development going on to bring it back in the primary industry. As of now, it is going for downcycling for the secondary use, either for making a road or for your shoe soles or plastic tires, etc., etc. However, all the metals which get recovered like aluminium, silver, your silicon, copper, they all go in the primary. So which is a good news. Very important slide. As I showed in my previous slide, by mass, glass is 70%, aluminium is 80%, whereas silver and other is less than 0.5%. If you see the distribution of material by value, which my previous speaker also said, the silver has highest of 47%. And extracting silver to purity is the silver lining. And that is what is going to encourage solar panel recycling. See, glass, by weight it is 70%, but by distribution of material value, it is hardly 8%. Aluminium almost matches, like 18%, but by value it's more. I'll come to it, why aluminium is useful. So you have to understand that by weight, whatever material is the least, by value, it has the highest distribution. If you see the distribution by value, it is highest, but by weight, it is the least. So it is a totally juxtaposition, contradictory. Now, 3 simple stage for solar PV recycling, which is now globally being followed. Then whatever be the methodology you use, whether thermal recycling or mechanical recycling or using some chemical recycling. The first is separating the junction box and the frame. That's the first step, which is very much common. By doing so, also you reduce on your logistic cost because aluminum can be traded at any local market. And if you remove the junction box, you reduce your logistic cost because you reduce your volume. The second step is separating the bonded layers. So, in a typical solar PV module, the solar cells are bonded between 2 polymer sheets, which is further laminated to the glass and then heat pressed or laminated through a back sheet. So all these 4 layers, the 2 encapsulants, the back sheet and glass, if you separate, that becomes stage 2, which is where you would have almost achieved 95% of your recycling process. Roughly, I'm giving ballpark figure. Your stage 3 is recovery of your precious metals or all the metals, whether they may be precious to some countries, but not. So copper, silica, silver, lead, and aluminium. The silicon that currently gets recovered is of 3N, which is the purity figure of 99.999. But now there are R&D going on and they have achieved close to 6N, which is required by the solar PV industry. So 99.999999, that's the purity. Silicon is getting recovered out of recycling. As I said, my presentation is more focused on a case study in India. India is a very strong case for early loss and repowering. Let's understand. Why early loss? Because it is highly unlikely these modules may last 25 years due to broken glass, cracked cells, cracked back sheets, due to weather conditions. These are panel discoloration, which is very likely to happen, technological advancement, which is repowering. So every 3 years, if you see, a new solar PV cell technology is coming, which is superior in performance, in efficiency to its predecessor. Now, when my investment is recovered, when my ROI is achieved, why should I continue using that solar panel? Why can't I go for a high efficiency solar panel to generate more power? Understood? And that is called as repowering, which is substituting my existing low efficiency solar PV panel with a high efficiency PV panel technology. And this is what is going to lead to repowering. Now, the second hand life will be there, but you will need to again test it through a laboratory to get a certification on its performance. Secondly, since the efficiency would have degraded over time, the second hand buyer may not find it useful to buy if the price is same as a newer technology with a higher efficiency. If the price is the same for a second-hand solar PV module with a higher efficiency existing or the then existing PV module, then it will be forced to go as end of life. So that's repowering. The most possibility of an early loss would be reduced power output. There is a study available even by the GIZ in India that solar cells degradability will be fast in India owing to a compromise on the quality. And already the results are being seen. So repowering, a big business in future owing to early loss and rapidly evolving superior cell technologies, in short. As a result, what we had earlier estimated the 2047 material recovery, this will far more outgrow. Could be by 30%, 50%, we don't know, depending on the early loss factor. And that will call for more material to be mined. So more opportunity for recycling, but that doesn't mean that you develop substandard quality so as to increase your recycling business. In fact, now globally they are working to make new solar PV module such that it becomes total user-friendly recycling, which is separation of all the materials used is very easy and in a sustainable manner. You don't have to put in too much efforts. That's what the future would be looking. A study done by us shows the potential states in India for recycling, largely around the western and the southern region. We have also estimated will require in excess of 300 recycling centers. In fact, there will be very smaller modular deframing centers coming up in India now. As I said, the moment you separate the aluminum frame and the junction box, you reduce on your logistic cost because you reduce the volume. The aluminum frame occupies a considerable space. And both these can be traded in the local market, fortunately. These are the employment opportunities per megawatt we anticipate as 7 man-days. However, this will vary depending on the conditions. Conditions meaning how the technology for recycling is evolving. But with one of the technologies where we have established licensing, we have found that per megawatt it will be 7. So plenty of employment opportunities we are seeing. Why India is currently an advantage. In fact, as a matter of fact, this will be applicable to the entire South Asia. If you see the mobile data cost per gigabyte, it's cheapest in India compared to European Union, US, or the world average. I think the same may follow in South Asia. So it may be that South Asia may become the global recycling centers. All the PV modules or the panels, as we say, that attain end of life may come in India or in South Asia for recycling later, owing to low cost of labor. Okay. And also because they will be able to fulfill their requirement for critical minerals. So hopefully government may come out with some kind of regulations on permitting imports of end-of-life solar modules. As of now, there are severe restrictions on any import of scrap coming, whether it's your shipping or e-waste or whatever you may say, because they pollute the environment. There is a saying, if you discard something in somewhere else, you pollute somewhere else. So it doesn't mean that the European Union feels they don't need to have the scrap panels or the end-of-life modules. They don't keep it there, but just send it to some other countries or dump it. They are then polluting that environment of that country. They are polluting the environment of that country. Now, how green is really green? Mining waste tinted of earth addresses climate change. Very important, recycling of glass and aluminium saves energy up to 75%. Mind you, this will also recycling will aid in climate change. Recovered materials can repower instead of landfilling, creates employment opportunities, makes countries self-reliant. In India, there is a program called Atmanirbhar, which is the local language meaning be self-reliant, let's not depend on other countries to fulfill your materials needs. See the merit here. Standard production of a 1 kilowatt requires around 3000 electrical units of kilowatt hours of energy to make glass. The same recycled glass, if you use, it will use almost 75% less. In fact, now the technology which we have obtained from Germany will use 90% less energy to make the same solar glass. Similarly, for your aluminium, energy constitutes 40% of the production cost. So scrap aluminium converted to virgin aluminium constitutes only 5% of your energy. See how you are benefiting. You may probably get carbon credit certificates that can be traded and make your recycling business further beneficial. lucrative. It's also very important to note glass takes over 4,000 years to biodegrade. So do we need to make the Himalayan region of the glass with such massive targets the worldwide about solar PV happening, particularly in Asian region? As we saw, they are going to be about 68%. And hence, recycling glass will be key. India has also come out with a critical minerals mission, and it's also now extending production linked incentives for complete domestic manufacturing of the entire life cycle, right from making polysilicon ingots, wafers, to your solar cells, to your modules, and then also to completely recycling. So it's called as PLI scheme, production linked incentives. There are incentives for setting up such industries, and they are encouraging the entrepreneurs. As I said, the right wordings used would be right intent but confusing content as of now. Intent is right to recycle, but the contents are still confusing to people. A separate renewable energy waste policy is required. We cannot compare solar PV module with our standard electrical and electronic gadgets like our laptops, computers, fans, toasters, and your washing machines and your television sets. It's not a consumer item. Though it generates electricity, but it has an identity of itself. The advantage with having a renewable waste is there is also massive opportunity for wind turbine blades to be recycled. By volume, they are so massive. And India is today, the fourth leader in wind energy production. I'm sure there are a lot of other South Asian countries who have. And these are polymer-based resins which cannot be landfilled or take several years to biodegrade. So if renewable policy is bought, we can bring several other renewable technologies under its ambit. Currently, e-waste recycling is in an unorganized sector, and they are trapping producers with e-waste certificates, by manipulating. Glass and aluminum suppliers also be made accountable, because why should only a PV module manufacturer be done? Glass and aluminum by weight are highest. No clarity on retired orphan panels. You understand? Now, if you are importing a solar PV module, and if the importer has shut down its business, then to whom does the ownership of the EPR come to? There's no clarity. Does that mean that the module will go to landfill? Hence, we call them as orphan panels. So even they need to be addressed. And this solar panel recycling, as I said, should be made applicable post removal of the aluminum frame and junction box. It will make more sense then. Scrap metals as they are locally tradable and saves transportation. Recycling target be 100%, not the formula, as I said, of e-waste of 60% first year to 90% in the fifth year. Recovering metals from solar cells secures your critical minerals, and avoiding mining, of course, reduces CO2 footprint. It's very much common. To encourage, the first 1 million tons of solar panels should be subsidized by the government. And that's what probably the government India is working on it, because today it is taxing on the module manufacturers. They had never built in this cost. Perhaps a pollution tax on solar modules can be used. So every solar panel that comes out, a percentage of solar pollution tax be imposed, and this could be pooled. This money can be pooled to use for the recycling cost. A collective producer responsibility association can be made for some of the established recyclers. So instead of every manufacturer setting their own recycling units, they can collectively come forward and support an entrepreneur by way of their environment sustainability governance, or whatever you may say, or as a corporate social responsibility. Now, there is no clarity on the insurance. If early loss happens, because the solar PV panels in India are insured, the insurance company will claim that it is their property since it has been claimed as dead. So insurance companies, whether they will be applicable for the EPR certificate, there's no clarity. It's being worked out on it. If you fail to recycle your PV module because there is regulation, then every municipality or a municipal corporation has a TSDF cost, which is your storage disposable facility. Trash storage disposable facility cost is there. Because if not you, then they will have to recycle it. So there is a disposal cost, and that is yet not defined. For most of the things which is disposed, whether it's your cement, your concrete, your building materials, your rubber, your plastics, there is a cost defined, which is equivalent to the cost of recycling. As I said, design future panels as recycling friendly, and the Producer Responsibility Association can collectively manage the entire ecosystem. I won't go in details through the roadmap because this is applicable to India, but a green chemistry approach will be required, which is very important. So instead of going for a thermal or a chemical-based recycling, which uses acids, a sustainable recycling is the need of the hour. Then portable recycling is needed owing to vast geography of India. Okay, and identify the socio-economic benefits equally. As I said, reducing mining cost and health of the workers is going to further aid in government pushing through in South Asia to make mandatory recycling. Perhaps India is happening to be a global benchmark. Let's say South Asia becomes the global benchmark. I don't want to be biased to our country. As I said, ESG governance can help. Not by law, but by moral responsibility, we must commence recycling. If I is replaced with we, the illness becomes wellness. So let's not make solar PV modules as ill. Let's make them as well. And the responsible recycling certificates may be given to every manufacturer or a producer, and R2 recycling. So recently we entered into an Indo-German cooperation for sustainable recycling with Lux Chemtech, Germany, which is an award-winning technology funded under the European Union called as Photorama. And they have been able to separate the multiple layers, which otherwise are either shredded or using thermal means separated, but they have used the water jet technology. Through the water jet, all the layers are separated. Glass is retained in its original value. I repeat, glass is repeated in its original value. The polymer sheets are totally separated from the silicon cell, and the residue is very clearly separated then. So once the glass is separated from the polymer sheets are further dipped in water. They being light, the polymer sheets float on the top, and the residue of the silicon metal remains downwards. So stage 2, they have achieved easily. Of course, as I said, stage 1 is very easy. Mechanical means of separation of deframing, that is removal of the aluminum frame and junction box is done. So virtually 95% of the problem is solved. And when you have separated the glass and the polymer sheets, the residue which is left, there are several sustainable technologies available to separate the metals within the silicon cell, whether it is your silicon, your silver, your copper, your tin, and the lead. All these can be easily extracted. There are technologies. You can go through this link or you can go through the PTI news. And I'll share you some infographics. So how the hazardous material go in the making of the solar PV module. You have your antimony in the glass, the lead, then of course even your silver has pollutant in it. Okay. However, nobody disposes silver down in the landfilling, so extraction makes sense. Then you have glass, as I said, which takes more than 4,000 years to biodegrade. You have your polymers, which are very long to biodegrade. And then, of course, the silicone, after all, because the silicone paste is used to bond the frame with the glass, even they need to be recovered. What would actually make sense is to calculate the carbon footprint of a PV module made. The generation is no doubt eco-friendly, but manufacturing, is it? That's a big question mark. And if there is a carbon footprint to make a solar PV module, then reducing this carbon footprint becomes the uh, responsibility of the producer. And in order to fulfill this responsibility, they have to sustainably recycle the PV module. As I said, there should be a renewable waste policy instead of including in e-waste policy. And yes, we can do it. It's possible to extract all these metals from the end-of-life solar PV module. It was challenging 10 years back, but yes, we can do it. Circular economy is key to sustainability. Waste is not a waste until we waste it. One profits most who serves waste. In nature, there is nothing as such waste. In nature, nothing is wasted, everything is recycled back. So instead of using, the typical reduce, reuse, recycle, we don't want to reduce a solar PV module. We redefine the 3 R's as recycle, reuse, and regenerate, unless you want to reject them. Wow, wealth out of waste. Trash is treasure. These are some of the photographs of the end-of-life solar PV module. So plus is, as I said, my heading was module materials recovery from recycling. Surplus is the solar power from the module material. So what you get surplus out of the modules is the energy, the power that you get. So from this surplus, what is the plus? Plus is the module materials. And us is the producers, we the producers. So let's extract the plus out of the surplus for all of us. Correct? Let's extract the plus out of the surplus by all of us and leave the sur to our customers. Thank you very much, and I end my presentation and open to any questions if you have found something not understood or if there are any clarities.
Thank you, Mr. Jaideep, for your presentation on the most important thing is that in the neighbors of the SAARC region, India is going ahead in establishing a recycling plant for solar panels, which will benefit for most of the member states, because as pointed out by the presenters that the deployment of solar is been nearly 10 years for some of the countries, and in some of the countries of SAARC region especially, is at early stage of deployment. So this gives the way forward for how we should focus on realizing the benefits of solar panels at the end of their life. And particularly, so when we have a neighbor, it will be easier for the member states to share technologies and experience from what the steps is being taken till now by India. So with this now, the floor is open for question and answer sessions. So if anyone has any questions, please, the floor is open.
How many participants are there, by the way?
33.
33.
But,
Very nice.
So in some of the places, you'll see there is only one login, but some group has gathered.
So, namaste. Somebody has raised a question.
Yeah.
Saugat Baral.
Yeah, please go ahead. Anyone?
Will it disrupt recycling industry in the future? Can the speakers highlight what is the current condition of R&D in producing solar technology that can be easily recyclable? Well, it cannot disrupt recycling. In fact, let me make it clear. I shared in my presentation. Sorry, Mr. Feng, unless you want to answer. But I'll very quickly tell. In fact, to make recycling, user friendly, it is very important that future module designs will have to be made such that you separate the layers. It will never disrupt. In fact, the business will grow in leaps and bounds. So don't worry about it. This should not prevent from making user-friendly recyclable PV modules. In fact, in Europe already they have achieved to a greater extent where you separate all these materials easily. So not to worry, it won't disrupt the recycling industry.
Anyone has any questions? So, Mr. Jaideep, you can see that there is only one person, but how many people are attending behind the login of one?
Can I take? They have all become experts now, so they
Yes.
have no questions.
So, anyone
Okay.
has any questions?
Okay, may I request the SAARC Energy Centre to work on making regulation mandatory in the South Asian region for solar PV modules or panels at the end of the life, because that will greatly help us. In fact, we can even export these raw materials to other countries for the PV modules, and I think you will have a very important role to play. Sorry if I'm being on the right side of advising, but it would be approved.
As
Yeah.
far as SAARC Energy Centre is concerned, we can only recommend.
Please.
It is up to the member states, because we are
I
not an
understand.
organization. So recommendations can be made, but
Please, sir, please, if you could do it, because we are seeing the positive results in India ever since it was made mandatory.
My colleague, Dr. Kiran, has one question.
Yes, Dr. Kiran. Namaskar.
Namaste. I'm Kiran Gautam, working here at SAARC Energy Centre as a program leader. Thank you very much, both the presenters. Very nice and timely topic that you have elaborated very much. And India is taking the lead in the South Asia in the recycling sector of solar panel. Yes, we were talking about the ESG also, so I was a little bit worried about the OHS of the workers. And in addition, I would like to know that is there any guidelines about the soil pollution? We mostly talk about the air pollution, but what about the soil? Because after the recycling process, the liters will go in the soil, and after all, in your background, I can see the greeneries through that. we have to take into our body, so we have to be very, very much careful on that.
Okay, good question. Good question, but let me put it that, eventually what the solar panel recycling ecosystem being developed is that nothing goes in the landfill. So if I refer to your question with the solar PV module, it won't damage the soil. Yes, as I said, if you're using hazardous acids to separate, then I don't think they will get the EPR certificates, because they'll have to disclose their process and how much CO2 footprint they have used, or if they're using, let's say, thermal means of incineration. So this is very important to note. You have raised a good question. I appreciate. However, yes, soil damage is happening, and the polymer materials in the solar PV module, they are getting landfilled, unfortunately, after recycling. So what right now the R&D is going on, and even what we are working, is that these polymer materials to be used unlimited times, right, by either downcycling or upcycling them, not landfilling, right? So definitely that will be addressed. You'll find a lot of content if you go through a Google search on sustainable solar panel recycling. And in fact, recently, there was a delegation from Taiwan which came in India, and they stressed upon that all future semiconductor industry or electronic industry must work towards user-friendly recycling. So there is another question. What is the capital equipment list and process setup required?
No, Mr. Jaideep, before that one, for today's presentation, we have the presentation has come to an end. We have no presentation on the recycling of storage batteries. So now we'll go with the next question.
Okay. Thank you, and namaste, and pleasure to everybody.
So I think if Mr. Fang can explain this one, how the panel distortion will happen and how to address the issues. Or anyone. Yes, look.
Dr. Fang?
Mr. Fang, the question is to you.
Yeah. I thought, Mr. Jared, please stay on. You can just Mr. Fang. Hello, Mr. Fang,
Yes.
are you online? Yeah.
Yes, I'm here.
Yeah.
So I'm looking at the questions. So the panel discoloration, right?
Yes. Yeah.
Yeah, this is very technological of the solar PV and the materials to increase the efficiency and the duration. But to be honest, this is not what I focused, because it's technology side. It belongs to another division. What Irina is focused on. So this part, to be honest, I do not have the knowledge on this. And but usually from my side, depending on my observation of the technology advancement, and I see that at least from US and Germany and most of the Chinese, the top level industries, they are focused on the technology research on addressing this part, but also the duration of the panel material to increase. But I'm not very quite clear about the specific technology on that.
Okay.
Okay, thank you.
I'll answer that. That's fine. I'll very quickly answer that. There are two reasons. One is, when a shading happens on a solar PV cell, okay, the voltage reduces. This is on the technical side, but I'll explain in layman's terms. When the shading happens, the cell cannot generate energy because there is no sunlight. And that creates a very high voltage indirectly, which is called as the negative voltage, which creates the hotspot. And that hotspot discolors your solar panel, which makes it dark. This is number one. Second reason is your quality of your solar cell. As I said earlier, it is a classical case of an early loss. So there are some compromises on the quality made, in which the solar cells may last up to 5 years, 8 years, and then they start discoloring, which results into reduced efficiency. But also it is important to note the cost is less, and this helps them gain business. So I can only tell that much.
So the next question is, what is the capital equipment list and the process setup required for commercial scale? I think Mr. Jerry, you can answer this one. It will be relevant to the questions raised by the member states or the participants.
Okay. I will put it. It takes about. Okay, Mr. Feng wants to answer.
Yeah. Please go ahead, Mr. Feng, if you.
Yeah, I can mention a little bit about our observation to the different, other regions, because I'm not quite clear about South Asia. But first, what I know that based on what I see, there are several centralized commercial scale. Commercial scale, we mean that in Europe and in China, it means that the full operation, like at least the treatment of 20,000 tons of solar panels every year. This is the benchmark of the operation to make it profitable. And in that kind, I see that at least $3 to $5 million for full operation facility that treat and recycle of this kind of 20,000, at least 20,000 tons of solar PV panels yearly, it is observed in Europe and China, but also depends on the labor cost and where you got the equipment, but also the cost can very significantly depends on the environment, because the investment not only the treatment like the mechanical treatment and also crushing, and also this is a line, but also a lot of investment are necessary to fulfill the local environment requirements, such as the treatment of the waste liquids. In Europe, it quite be expensive. And also, another part of the high cost is not only the treatment, but it's about the infrastructure, how you collect it and store it, and also the pre-treatment. This is also depends on not only the treatment facility, but also how the local government and also the let's say the industrial association sometimes play a role in building and enabling the infrastructure. This is also not will affect, sometimes increase the capital needed for the commercial scale. But so far, I would say in Europe, only like Rossi or PV cycle, this is some observed they are in recycling, but they are still facing the big problem is they do not have enough feedstock. This is the biggest problem, let's say, because if we have a capacity of the facility could treat like 20,000 tons of the end-of-life solar PV, that's a baseline to make you profitable. But if they do not have enough feedstock, they will not get enough return. And also same is facing as one of the largest barrier in China, in US. So this is not only the equipment, but also about the infrastructure, which will affect the investment significantly. And also the cost effectiveness depends on the local feedstock. Yeah, I'll stop here. Yeah, thank you.
Okay. Mr. Jaydeep, do you want to add something?
Yes, I think the investment, as far as India is concerned, for setting up a typical 10,000 tons per year is anywhere in the range of 1 million or 0.8 to $1 million. And we are making attempts to bring it down further. Yes, rightly used by Mr. Feng, the observation that the feedstock is an issue, but in India, at least we are not likely to face this, because our program started in 2010 and we have now started getting plenty of PV modules which are stacked. In fact, as of now, what we are given to learn, close to 20,000 tons of solar panels are already lying, and they need to be processed. So this may not be really an issue as far as India is concerned.
So the next concern is how to ensure efficiency of the modules and cells after recycling. Any one of you can answer, please? Mr. Feng or Mr. Jaydeep?
No, after, okay.
Yeah, please pass and give to Mr. Feng.
Sorry, let me share a little bit. I think that from our side, there are two different, because I'm not sure efficiency of the module after recycling, because for us, we have two different understanding, especially I would like to all the stakeholders to take attention. The first is efficiency of the recycling actually is quite high. As Jaydeep already introduced in his presentation, the recycling share quite high actually globally. If you look at we see that most of the major markets overall recycling rate can be more than 92%. But also another is efficiency of the module or cells. After that, we also look at after, it's not recycling, we say reuse. This is one of the largest area we haven't touched because of many of the barriers, because If we say it's not only the PV but also battery, many of that, let's mention one thing. If we all recycle the solar panel, let's say 20 billion, it's all based on the material you sell. You sell the powder. But one of the observation we see that, especially from the research side in US and Europe, and also Republic of Korea, they are researchers trying to see how to reuse, how to keep the solar cells. Because solar cells in many of the area, at least 20 or half of the price in production price of new solar panels. If we can keep it and break and still reuse it of the solar cells, it can significantly save the cost. This is one of the area untapped, but also technical barrier. And this also mentioned one thing that to ensure and enable a second-hand market for like this, reused components, they still lack all the factors like certification, testing, and also the quality infrastructure. This is something like, I would say, the regional platform, regional cooperation platform can play a very, very important role in promoting this. So I will stop here. Thank you.
Mr. David?
I
You want to
think
add on?
if I understand the question correctly, first of all, after recycling, you have separated all your materials, right? So you can't measure an efficiency of that. But if I understand correctly, what they are telling is that second life of a solar PV module, if it is discarded, well, that depends on what quality of PV module you have used and what duration. Ideally, for the first year, you see in first 6 months, the efficiency drop is of the order of 3 to 4%. And that is by nature. Then it stabilizes and the drop of efficiency every year is about 0.5%. So you may say at the end of 10th year, you lose about 5% of your efficiency, right? However, it is observed for most of the modules in India that this drop of 5% in efficiency is happening much earlier. And as I said that, supposing if your PV module efficiency when purchased was about 14%, if it has dropped to 12%, let's say for argument purpose, after 5 years, and if you have a new technology that has an efficiency of 20%, why will one use an old module with a lesser efficiency with hardly any cost advantage? So this is a big challenge. There is a right to repair, but solar PV modules can never be repaired. And when we had this debate at the time of the regulation being formed in India, it was made very clear that second life should be discouraged at all. If they want to have it, it will have to undergo further testing by the certified laboratories to give the efficiency figure so that the end user is aware about it. Now, there are various other, jugards, as I say, or they are using different means of using the solar PV module for covering their roof sheets or walls. Even they should be discouraged. Hence, it was made very clear that if you are declaring a solar PV module at the end of the life, it has to be recycled to extract the precious metals, the critical minerals. Don't use it for your walls of your house or your roof, and it's ridiculous. So anyway, answering the question, it all depends, but the efficiency drop is anywhere between 5% to 10%.
So considering the time allocation, we'll take the last question. What revenue sharing models or financial incentives are used between solar recycling facilities and asset owners? Anyone of the speaker can attest to this question, please?
See, this will be totally based on from country to country. Okay. Asset owners are in India not subject to recycling. I think I explained in my slide, it's the producer. So let's say I'll explain in a layman's term. If you're wearing a shirt or I'm wearing a jacket, I'm not responsible for recycling. The company which has sold me, who has made it, they are supposed to collect. See, even in case of your mobile phones, now you'll find most of the mobile phone dealers or traders or sellers, they have kept a box, at least in India there, where you can dispose your unused mobile, which has to go to an authorized recycler for generating the EPR certificate. So, first of all, I'll clarify that the asset owner has nothing to do. Yes, as I said, that collectively, if all the manufacturers can pool in a money to support a recycler, to set up one common recycling facility, yes, that is possible. That's a good idea, in fact, in the initial period. And as the volumes would grow, then they become independent. So revenue sharing model will largely depend. And initially, as I also mentioned in my presentation, the governments must subsidize the first at least 10,000 ton lot.
Okay, Mr. Fang, you want to add? Please go ahead.
Yes, I would like to add very briefly. First, I very much agree with Jadeb. It depends on the context, different countries. For example, from my side, I would say it's more about cost sharing of this practice because at least from what I see different markets, the revenue is very much based on what you sell the recycled material to the market. The market price of copper increase, that's your revenue increase. But we look, at least from our side, we look at the cost, how the cost varying by different companies. For example, if you look at in Europe, they have the extended producer responsibility. The extended producer responsibility, as Ms. Jadab, the presentation already in the K is the producer take the responsibility, financial responsibility of the take back, of treatment of the end-of-life PV. So the producer pay for that, pay for collection, pay for everything, who do that. But in China, if you look at that, the asset owner, the owner of the project, they are responsible for collect all the end-of-life solar panel, they transport it to the certificate recycler, they respond for everything for that. But in US, if you look at Canada is different. Canada, they do not have recycling facility. The owner and work together with local stakeholder and association, they transport it to US for recycling and they pay for that. So it's very much depend on, and also I would agree that still the revenue is still very not yet fully tapped because it's just the material sell to the need subsidy, need also how to properly reflect the externality of the environment of the whole supply chain. So I would say the policymaker and the policy regulators still have a lot of space to improve. Thank you.
So with this, we come to an end to this today's program. So first of all, lastly, before I end the session, so SEC would like to express profound gratitude to the presenters, Mr. Fang from Arena, Mr. Jaideep from India, for presenting mostly I should say the way forward of how we should gear up to be ready for the circular economy of the solar panels. So because this will be burning issues mostly among the sub-member states in times to come, because at one point of time, when the life of the solar panel expires, then there will be a huge quantity of solar waste this one. So at that point, I think the policymakers or the implementers will be not in shock. So at least by this, we are in some way suggesting or sharing knowledge among the members so that one day we have to face this situation, and so that we are well prepared of. So with this, thank you very much. So for the benefits of the participants, please do visit us in our websites and through social medias for the series of knowledge sharing sessions will be carried out in the future. And for the benefits of the participants, the presentation and recordings will be made available in our websites. And if you have any questions or inquiries, please you are feel free to contact with us. So thank you very much. Thank you all.
Thank you.
Thank you.
Ustaz,
And
malam.